See out here. So in this lecture, we'll start from question number 3.13. Okay. But after question point 3.110, why suddenly question 3.13? To understand question number 3.11, okay, you first need to understand this question. Okay. Question number 11 is very much linked to this question. If you understand this question, your question 11 will be solved. So after going through this question, we will go back to question number 11. Okay. So what this question says is that there is a rod of length 2a. Okay. There is a rod of length 2a. Okay. Now the midpoint of the rod at distance r, we need to find out the electrical field out here. Fair and fine. The rod has uniformly distributed charge. Okay. Where Q charge is distributed throughout the length of the wire. Okay. We have to find out the electrical field out here. This length is A, and this length is also given as A. So what is the electric field out here? Okay. Now these type of questions are very important in your magnetic effect of current, gravitation, this chapter. Okay. The main thing I want you to note out here is how I take the components of integration, or how the integration is done out here. Okay. Or how the component is taken out here. Understood? That should be your main focus out here. How am I taking the component? Okay. So out here, this rod. Okay. This rod. So I have to find out, let's take an element dx at length x. So I have to find out the electric field due to this element out here, isn't it? Let the charge on this dx element be dq. Okay, dq is the charge on this dx element. Fair and fine. Okay, now due to this element, the electrical field will be in this direction. No? The electrical field will be in this direction, isn't it? See, the electrical field will be in this direction, E, or d. D is nothing but the electrical field due to this dq charge out here. Fair and fine. Now I will take the component of this d along horizontal direction and along vertical direction. Why? Because it is much easier this way. So dE x is the component of this electrical field along this horizontal direction. dEx is nothing but the component of this electrical field along this horizontal direction. Okay, and dEy is nothing but the component of the same electrical field along the vertical direction. Fair and fine. So how do I know that what is the value of dx? So if I introduce an angle theta out here, I can easily say d or dex is equals to de cos theta, because if this angle is theta, this angle would also be theta, isn't it? Now see, the main objective out here, or how am I solving this question? Okay, so horizontal component, horizontal component, horizontal component, dex, dex is nothing but de cos theta, isn't it? Now what is the value of this de? The value of this de is nothing but, see, de is nothing but dq, or k. K is nothing but 1 by 4 pi epsilon naught. Okay, the constant of electrostatics, dq divided by r square, where r is the distance between these 2 points. So the distance between these 2 points, I'll write it as hypotenuse. Okay, or divided by h square. So dex, or horizontal component of electric field, is equals to d k dq by h square, k dq by h square into cos theta. So this much I have understood. Fair and fine. Problem is, what is the value of dq? See, If you observe out here, okay, dq is nothing but the charge of this much amount of element or charge contained inside this dx amount of element, isn't it? And what is the charge contained inside this dx amount of element is nothing but the total charge divided by total length into dx. Okay, and this total charge divided by total length is sometimes known as linear charge density, or lambda into dx. So in some question the total charge would be given, in other questions the value of lambda would be given, or linear charge density would be given. Okay, whichever is given, substitute out here, it won't make any difference. Understood? What am I doing is, what is the linear charge density? Linear charge density is nothing but q by 2a, isn't it? So what is the charge contained inside this elemental dx? Q by 2a into dx. Okay, and q by 2a is nothing but known as linear charge density. So if I substitute these values dq out here, what do I get? I get ex or dex is equals to k. What is the value of dq? Lambda dx. I substitute the value of lambda by q by 2a at the end of the question. Okay, out here, because lambda or linear charge density is equals to total charge divided by total length. Okay, k lambda dx divided by hypotenuse square into cos theta. Now pay very close attention to the thing I'm doing. Okay, the method by which I'm substituting this problem. Understood? So substitution, this plays a very important role out here. Substitution. Okay, the first thing would be, can I say tan theta is equals to x by r? Tan theta is equals to x by r. So r should be equals to x tan theta, or x should be equals to r tan theta, or out here x is equals to r tan theta. And why did I find out the value of x in terms of tan theta and r? Okay, because out here, part 2 of the problem, dx by d theta, if I differentiate this x with respect to theta, what will come? R, the differentiation of tan theta is nothing but sec square theta, or dx is equals to r sec square theta d theta, isn't it? So to substitute the value of dx, we have taken this to substitution. Dx is equals to r sec square theta d theta. Understood? And the third substitution would be, I have to convert this hypotenuse term also, no, in terms of acha. To convert the hypotenuse term, I'll say cos theta is equals to r by h. So cos theta is equals to base, which is equals to r. Cos theta is equals to base by hypotenuse, or r by h. R by h, or h is equals to r by cos theta. R by cos theta. Simple enough. Now, if I substitute the value of h out here, okay, and dx out here, what do I get? X component of electric field, dex, should be equals to k lambda. What is the value of dx? The value of dx is nothing but r sec square theta d theta. The value of dx is nothing but r sec square theta d theta. Okay, into cos theta, divided by h square, where h is nothing but r by cos theta, or r into sec theta. So I can write h is equals to r sec theta, because 1 by cos theta is nothing but sec theta, no? So if I substitute the value of h by r sec theta, what will happen? R sec theta whole square, or this can be written as r square sec square theta. R square sec square theta. Now this sec square theta and this sec square theta will get cancelled. This r and this square would get cancelled. So our x component of electric field will be dEx would be equals to k lambda by r cos theta d theta. Okay, cos theta d theta. Now if we integrate this angle theta with d theta, we'll get our answer. But the problem is, what are the limits to this integral? We have to integrate this, no? Okay, from 0 to ex, from 0 to ex. But what are the limits to this integral? To find out the limits to this integral, what you have to do, you have to draw two lines, okay, from the ends of the straight line to the point where electric field is found out. Okay, this angle, this angle would be phi a, okay, and this angle would be minus of phi b. Out here by geometry, you can already see that this angle and this angle are same. But all I am deriving is for generalized solution. Generalized solution means what happened if this was not of what happened if this length was not equals to this length. Okay, different type of questions can come up, no? So out here, that's why I have taken these two length different out here. For this specific question, this length and this length will be same. Therefore, this angle and this angle also would be same. So our limits of integration would be minus of theta b, sorry, minus of phi b to phi of a. So this is our limits of integral. Minus of phi b, whatever is taken downward should be taken as minus. So whatever is taken downward, okay, is taken as minus, and whatever is taken upward, okay, should be taken as positive. So this phi b, sorry, phi a should be taken as positive, and this phi b should be taken as negative. Fair and fine. So if you integrate this one, x component of electric field is equals to k lambda by r. What is the integration of cos theta? Sin theta, from phi a to minus of phi b. Okay, so ex should be equals to k lambda by r into sin phi a minus of sin minus phi b. Okay, understood? Now this minus phi b, what is sine of minus theta? Sine of minus theta is nothing but minus sine theta. This minus comes outside. So if this minus comes out and gets multiplied by this minus, it becomes positive. So this entire thing becomes plus sine theta b. So plus sine phi b. This is the result that you must remember. Understood? Now, for this specific question, what is the value of phi a? What is the value of this angle? See, for this specific question, phi a is equals to phi b. Okay, who should be equals to, acha, what is the value of phi b or phi a and phi b? See, can I say sine theta or sine theta is nothing but perpendicular by hypotenuse, isn't it? Perpendicular by hypotenuse. So is equals to sine inverse perpendicular. The value of perpendicular is nothing but how much? A divided by hypotenuse. What is the value of hypotenuse? Under root of a square plus r square. So the value of hypotenuse is nothing but under root of a square plus r square divided by under root of a square plus r square. Simple enough. So if I substitute this value of phi a and phi b out here, okay, what do I get? I get Ex, or x component of electric field, is equals to k lambda by r. And what is the value of sine phi a? Sine phi a is nothing but this value, okay, because phi a is sine inverse this value, isn't it? So sine phi a plus sine phi b. Phi b also has the same value. So a by under root of a square plus r square plus a by under root of a square by r square would be 2a. This would be 2a by under root of a square plus r square. So this is the x component of electric field. Okay, out here. Now in this specific question, the linear charge density is not given. The total charge is given. So can I substitute lambda out here? Lambda should be substituted by q by 2a. So this lambda should be substituted by q by 2a. So out here, this a and this 2a would get cancelled. Okay, so we are left with how much? Kq by r, kq by r, then 1 by under root of a square plus r square. So this is the x component of electric field. Okay, so we already found out the x component of electric field. Now we already found out the x component of electric field. Okay, now if you observe the diagram carefully for the vertical component, see the vertical component of electric field would be 0 because this portion, okay, the upward portion of the wire is pushing it downward and the bottom portion of the wire is pushing it upward. So due to symmetry, okay, the electric field at this point would be 0. Okay, but what happens if symmetry is not there in the question? Okay, what happens if symmetry was not there in the question? So we'll obtain expression for vertical component of electric field. Okay, for this specific question, because symmetry is there, because the upward portion of the electric field would get cancelled out by the bottom portion of the electric field, that's why the net electric field out here for this specific question is equals to 0. But what would happen if symmetry was not there? Okay, so if symmetry was not there, would follow the same type of analogy. dEy or vertical component of electric field is nothing but dE into sine theta, isn't it? Into sine theta. Okay, what is the value of dE? The value of dE is nothing but k lambda dx by hypotenuse square. So if we substitute the value of dEy is equals to k lambda hypotenuse square into sine theta. Okay, now lambda into dx. Out here I forgot the value of dx. Okay, now what do? We substitute dx out here and h out here. Okay, so dEy is equals to k lambda. What is the value of dx? The value of dx is nothing but r sec square theta d theta. So r sec square theta into d theta. Okay, what is the value of h? The value of h is nothing but r sec theta. The value of h is nothing but r sec theta whole square, which is equals to r square sec square theta. This should be equals to r square sec square theta, and we have a component of sine theta out here into sine theta. So sec square theta and sec square theta will get cancelled, r and r will get cancelled. Okay, the remaining part of the questions is nothing but k lambda by r into sine theta d theta. Okay, so vertical component of electric field is nothing but k lambda by r into sine theta d theta. Okay, now similarly, where do we have to integrate this one? 0 to ey, and out here minus phi b to phi a. So out here minus of phi b to phi a. So ey or vertical component of electric field is equals to k lambda by r into what is the integration of sine theta d theta minus of cos theta and the limits of integral are minus of phi b, the bottom portion, the downward portion, okay, is always taken as negative angle and the upward portion is taken as positive angle. So minus of phi b to phi phi. Now can I bring this minus outside? Of course I can. So let me bring this minus outside. Okay, so ey is nothing but minus k lambda by r into cos of phi a minus of cos of minus phi b. Okay. What is the value of minus cos of minus theta or cos of minus x? The value of cos of minus theta is nothing but cos theta only. Okay. What is the value of cos minus 45? This is same as cos 45. So out here, cos phi b would become, or cos of minus phi b would become cos phi b. So out here, this minus would get disappeared. Understood? So cos phi b. Understood the question that I did out here? So vertical component of electric field is nothing but minus k lambda by r into cos phi a minus cos phi b. And from the diagram, okay, phi a is equals to phi b, which is equals to cos inverse. What is the value of cos phi a? Base by hypotenuse. The value of base is nothing but r divided by under root of r square plus a square, isn't it? If you see this problem, for this specific problem, because of symmetry, okay, this value and this value would be same, and this would be equals to this one, so it is equals to 0. Or vertical component of electric field is equals to 0. But in case phi a was different from phi b, some other non-zero values would be obtained out here. Understood? Fair and fine. Now we would like to summarize what we have just learned. Okay, the first thing we have learned is the horizontal component of electric field would be k lambda by r sine theta from phi a to minus phi b. The vertical component of electric field would be Ey is equals to minus k lambda by r cos theta phi a to minus phi b. Okay. Now the third portion, what I actually did in the problem. The thing that I actually did in the problem was the objective of the problem. So what I actually did in this type of problem is I converted all the vertical terms and the hypotenuse terms in terms of this distance r or the horizontal length and angle theta. So I converted all these x, the vertical terms and the hypotenuse terms in terms of r and theta, and then I integrated it. Okay, so whenever such types of problem will come up, okay, convert all the vertical terms and hypotenuse terms in terms of r and theta, and then solve the problem. It will be much easier in integration. Okay, one more error that most of you make out here is you will take this dx to be r d theta. Okay, don't do that kind of mistake. Okay, caution. So I must write a caution out here. Don't make dx, or don't make dx is equals to hypotenuse into d theta. Hypotenuse into d theta. That means this approach is wrong. You cannot make dx is equals to h into d theta. Okay, why? Because it is not a circle. Because it is not a circular arc. It is not a circular arc. That means out here, this line is not a circular arc. Therefore, you cannot make this dx element into h into d theta. Understood? You first have to take this tan theta is equals to x by r. X is equals to r tan theta. Then dx by d theta is equals to r sec square theta into d theta. So dx is equals to r sec square theta into d theta. That's the way you do it out here. Understood? Now you have got the electric field at horizontal component and electric vertical component of electric field at this point. Okay. There are two main important conclusion or further conclusion from here. Okay. What happens if the length of the wire is infinite? Okay. Further derivations or further analysis of solution. Okay. What happens if the length of the wire is infinite? From minus infinity to infinity. Okay. What is the value of electric field at distance r from the wire? Okay. A charge rod of infinite length and lambda charge density. Okay, what is the electric field at this point? So how do you solve? See, when the length of the rod is infinity, no, this phi a will become, see, as I go towards infinity, see, as this length is zero, what will happen? Phi is equals to zero. As I'm increasing towards infinity, no, as I'm increasing towards infinity, what will happen? The value of phi a will tend to be 90 degree. So similarly, for infinity, for infinite length of rod, length of rod, okay, phi a is equals to how much? 90 degree. Okay, phi a is equals to 90 degree, and similarly phi b will also equals to 90 degree. So if you take this angle out here, for infinity this angle would be 90 degree. Understood? At 90 degree, this line means the length of the rod is very large from. Okay, so out here phi b would be minus 90 degree or minus pi by 2. Okay, so the x component of electric field, k lambda by r sine 90 minus of minus sine 90. So it is k lambda by r into 2 sine 90. So ex would be equals to k lambda by r into sine 90 minus of minus 90. That minus would come outside. So 2 into sine 90, 2 into sine 90, and the value of sine 90 is 1. So x component of electric field is nothing but 2k lambda by r. Simple enough. Similarly, due to symmetry, the y component of magnetic field is equals to 0. Or if you put cos theta 90 out here and minus 90 out here, you get the same value of y component of electric field to be 0. Okay. So this is one type of analysis of this problem. The second type of analysis would be for semi-infinite wire. Okay. The first type of analysis is for infinite wire. The second type of analysis is for semi-infinite wire. Semi-infinite wire means a long, wait a minute, a infinitely long rod carrying charge or carrying uniform charge distribution given as lambda. Lambda is the linear charge density. Okay. You are asked to find out the electric field out here at this point at distance r. The difference between this problem and this problem is, in this problem the top portion also has some charge, the bottom portion also has some charge, but out here the bottom portion doesn't have any charge. There is no charge at the bottom. So these kind of problems are known as semi-infinite wire. Okay, so for semi-infinite wire, acha, for semi-infinite wire, what is the value of phi a? What is the value of phi a? Phi a will tend towards 90 degree. So phi a is equals to 90 degree. Similarly, what is the value of phi b? Phi b doesn't move down, no? So phi b gets stuck at 0. So out here phi b will be equals to 0. So if we substitute the value of ex and ey, so horizontal component of electric field ex is equals to k lambda by r. I'm just applying this formula out here. K lambda by r sine of 90 minus of sine of 0. So it is nothing but sine of 90, which is equals to 1. So x component of electric field would be k lambda by r. But out here, okay, the y component of electric field would not get cancelled. Why? Because there is no bottom part to cancel out the top part, isn't it? So the bottom part of the electric field, that means there is a component of y component of electric field that would be due to this length of y. So if I find out the y component of electric field, Ey is equals to nothing but minus k lambda by r, okay, cos, this is nothing but, see, cos phi a. What is the value of phi a? Cos 90 minus of cos of minus 0. See, any number into 0, okay, is always 0. So minus 0 is also 0. So minus of cos 0. Okay, minus of cos 0. Cos 90 is nothing but 0. Okay, cos 0 is nothing but 1. So Ey, or y component of magnetic field, would be nothing but this minus and this minus cancels out each other. So it would be k lambda by r. So the y component of magnetic field out here, sorry, y component of electric field out here is also k lambda by r. Now I want to note something out here. Okay, this minus, what does this minus signify? Okay, if you pay attention out here, the x component of electric field would be in this direction, no, away from the wire. What would be the what would be the vertical component of electric field, or what would be the direction of vertical component of electric field? It would be downward. If you apply some logic, the vertical component of electric field would be downward, no? If positive 1 coulomb charge is kept out here, the rod would push it downward. Okay, so the minus signifies out here, the minus out here signifies is that while derivating, okay, we took the means upward portion to be positive and downward portion to be negative, no? Understood? Okay, so while derivating we took the upward portion to be negative and downward portion to be negative, and upward portion to be positive. So minus signifies out here is if plus comes out, okay, if the net electric field is positive, that means it will be in downward direction. That means this minus out here is just assigning the coordinate system. Okay, if the electric field out here is positive, that means it is in downward direction. If the electric field out here is negative, that means the electric field is in upward direction. Understood this much? Okay, the main conclusion out here is, and now we'll apply this conclusion in the next question. See what I have done till now. All I have done is I've taken a wire, made dx, okay, and converted all the vertical lines and the hypotenuse lines in terms of r and theta. Fair and fine. Then I simply applied k dq by r square or k dq by x square, and I substituted those terms and find out ex and ey. Okay, ex is simple enough. This minus in ey signifies that in downward direction, okay, see if the answer comes as positive, the total answer comes as positive, or the total value of electric field in y direction comes as positive, okay, that means it is in downward direction. If the total value of electric field in y direction comes out as negative, that means it is in upward direction. Understood? Fair and simple. Okay, and those are only for positive charges. That means while calculating, okay, just observe the type of charges. Don't blindly put the direction of electric field from this formula. Okay, just observe the charges and the nature of charges. If the charges was negative out here, what would be the y component of electric field? It would be upward, no? Because these charges are pulling this plus 1 coulomb towards themselves, isn't it? So in an electrostatics, it is always wise to see the direction of, see the type of charges and see the symmetry of the shell, okay, instead of blindly following the calculations. Understood? The two main important formulas that you have to remember out here is this formula and this formula. And the special cases of these formulas are for infinite rod, okay, this one for semi-infinite rod, these two formulas. Understood? Fair and fine. So sometimes in question, okay, instead of giving infinite length of rod, in the question it is given as a very long rod. So whenever you hear question such as a very long rod, that means they are taken the length as infinity. Okay, in your question, if you appear or if you come across the question a very long rod of means whatever length, or the length should be not be given. Okay, that means you have to assume the length of the rod to be infinity out. Okay. Now, before jumping back to question number 11, we'll just quickly do part B of this question. Okay. Part B of this question is asking nothing but the same rod, okay, of length 2a, of same charge Q, that is distributed throughout the length of the wire. Okay. The same charge Q is out here. But out here, instead of being asked the electric field out here, instead of asking the electric field out here, they're asking the electric field at this point, which is r distance from the end of the wire. Okay, so you have done similar types of question in gravitation, moment of inertia. Okay, moment of inertia, similar type of integration has to be taken. Understood? Recall the moment of inertia of a straight rod. How did you derive it? Or how did you take the elements? Similar kind of elements had to be taken out here. Dx, okay, dx amount of length, which is situated x from the point where electric field is to be found out. Okay, by common sense, we can derive that the electric field is in this direction. So dE is equals to k dq by x square, isn't it? X square. What is the value of dq? The value of dq is nothing but lambda into dx, or q by 2a into dx. I'll just derive this entire question using lambda. At the end, just substitute means lambda by q by 2a. Okay, it will have the same effect. It doesn't make a difference. I'll be using dq is equals to lambda into dx. You just substitute q by 2a in the answer. Okay, it doesn't make a difference. This is nothing but the linear charge density only. Total charge divided by total length is nothing but the linear charge density, isn't it? So dE, or net electric field, is equals to k. What is the value of dq? Lambda into dx, lambda into dx divided by x square, isn't it? Now, what are the limits of integration from 0 to electric field? Okay, what is the starting point? The starting point is out here. So the value of x as starting point is nothing but r. So the lower limit of integration is r. The ending value, okay, the ending value or the upper limit of integration is nothing but x is equals to r plus 2a. So the upper limit would be r plus 2a out here. E is equals to k lambda x to the power minus 2. To integrate x to the power minus 2 dx, so x to the power minus 2 dx is nothing but x to the power minus 2 plus 1 divided by minus 2 plus 1. Okay, and when we minus 2 plus 1 is nothing but minus 1, minus 1 out here. Okay, and in the denominator minus 2 plus 1 is nothing but minus 1. So if you send this minus out here, or if you send this minus outside, okay, what are the limits of integration? The limits of integration is nothing but r to r plus 2a, or net component of electric field or total electric field minus k lambda into 1 by x. This x inverse can be written as 1 by x, 1 by x. So it is nothing but 1 by r plus 2a, 1 by r plus 2a minus 1 by r. Okay, now if you multiply this minus inside the bracket, it will be nothing but total electric field is equals to k lambda into 1 by r minus 1 by r plus 2a. Simple enough. Now this is the same question we have discussed before. Okay, so infinitely long wire of charge density lambda. Okay, see, a very long wire, a very long straight wire. If this keyword is given, that means infinite. Okay, infinitely long. See, in this chapter of electrostatics, in a chapter of gravitation and magnetic effect of current, okay, whenever you hear a very long straight wire, that means most of the time they mean a very infinite length of wire. Understood? Now the question is asking us to find out the electric field out here at distance, acha, at distance y from the thread axis, at distance y from the thread. Okay, so instead of r, they're using the variable of y. Okay, what is the electric field due to infinitely long wire? K lambda, or 2k lambda by r. Out here the variable of r is replaced by variable of y. Understood? So before we solve the next question, a quick time for revision. Okay, for a circular arc of phi angle, the electric field is given by kq by r square sine phi by 2 divided by phi by 2, while charge density is given by q r by phi, or total charge, which is equals to q divided by total length. Total length is nothing but r into q, or sorry, r into phi. And one more thing, this electric field would pass through the perpendicular, or sorry, would pass through the angular bisector, that means half of this angle, isn't it? This line of electric field is cutting this angle phi into half. Okay, for a straight rod, okay, the x component of electric field is given by this value k lambda by r sine theta from phi a to minus phi b. That means the upward angle is taken as positive, the downward angle is taken as negative. Ey is given by the same formula. Now the special cases of these two are for infinitely long rod, phi is equals to 90 and phi b is equals to 90. So Ex becomes 2k lambda by r and Ey becomes 0. Okay. For semi-infinite rod, phi a becomes 90, phi b becomes 0. So Ex is equals to k lambda by r, Ey is equals to k lambda by r. And the direction of electric field in all of these examples are assumed by assuming the charges out here are positive. The charges out here are positive. Okay. If the charges was given as negative, then the electric field would be in the opposite direction. That means this E out here would be in this direction, this Ex would be in this direction, Ey would be upward. Ex would be in leftward direction, Ey would be upward, Ex would be towards left. Understood? So all of my formulas are derived assuming the ring, the circular arc, or the rod are positively charged. Understood? Now in this question, okay, there are two diagrams, diagram A and diagram B. We have to find out the electric field at point 2. Okay, so can I say for this diagram, it is length made up of two semi-infinite wire and a circular arc, and even this diagram is made up of two semi-infinite wire and a semicircular arc. Okay, so first I'll solve part A of the question. So see, now this wire, okay, the linear charge density is given as lambda, isn't it? The linear charge density of this wire is given as lambda. Okay, now this entire wire can be divided into three equal parts, or three parts. The first part, the second part, and the third part. See, the first part and the third part are nothing but semi-infinite wires. Okay, these are extending up to infinity, because in the question this length or this radius is much smaller to this length. Understood? And this is nothing but a circular arc. Okay, so what is the electric field due to this first wire at point O? The x component of electric field due to the first wire would be Ex1, and the y component would be in this direction, Ey1. Okay, similarly for the third wire, the x component would be in upward direction, Ex3, and the y component would be in this direction, Ey3. The magnitude of Ex1 is k lambda by r. The magnitude of Ey is also k lambda by r. This is also k lambda by r, and this is also k lambda by r. Okay, if you see the revision. Now see out here. This component Ex3 will cancel out this component, isn't it? This component of this wire would cancel out this component of this wire. So this component and this component are getting cancelled. Okay, now this component, okay, of this wire and this component of this vertical wire would also get cancelled, because they are of same magnitude and opposite in direction. The only remaining component would be in this direction due to the circular arc. And what is the magnetic field? Oh, sorry, what is the electric field due to a semicircular arc? E due to arc is nothing but kq by r square into sine phi by 2 divided by phi by 2, isn't it? But instead of giving the total charge for this semicircular wire, they have given the charge density. So can I say charge density is nothing but total charge divided by total length. Total length of the semicircular arc is nothing but r into phi. R into phi. Out here. Phi is equals to 90 degree, isn't it? Phi is equals to 90 degree. Or from this equation, I can also say that Q is equals to lambda into R phi. So if I substitute the value of Q out here, what do I get? But electric field due to R is equals to K. What's the value of Q? Lambda into R phi divided by. Acha, let me write it a little bit downward, okay? So it doesn't get cluttered. Electric field due to R is equals to K lambda R phi, which is the value of charge of the earth, divided by R square into sine pi by 2 divided by pi by 2 of this R, okay, would cancel out this R, this phi would cancel out this phi, and these two would go upward, okay. So what you are left is with 2k lambda by R sine phi by 2, isn't it? Let me write the sine phi by 2 little bit close. Sine phi by. Now what is the value of phi out here? The value of phi is nothing but 90 degree. So sine 90 by 2. Sine 90 by 2 is nothing but 45. So this phi by 2 will get converted into sine 45. What's the value of sine 45? 1 by root 2. So sine 45 is nothing but 1 by root 2. So if you calculate 1 by root 2 out here, or 1 by root 2, the electric field due to circular arc would be 2 by root 2 k lambda by r, isn't it? Okay, fair and fine. So the total electric field at this point is due to the circular arc only, no? So E total, the total electric field is due to circular arc, which is equals to 2 by 2 k lambda by r. Okay, because the electric field due to this component and electric field due to this component already got cancelled. Okay, now let's solve for this problem. This is also a semi-infinite wire. This is also a semi-infinite wire. The linear charge density out here is given as lambda. Even this setup can be divided into three parts: wire 1, wire 2, and wire 3. Wire 1 is this much part, isn't it? Wire 2 is the semicircular arc, and wire 3 is this much. Okay, this is wire 2 and this is wire 3. Now if you observe carefully, due to wire 1, the x component, okay, ex1 is nothing but k lambda by r, and y component will be in this direction, ey1. Similarly, due to the third wire, okay, the x component of electric field would be in this direction, ex3 or ex3, and the y component would be in this direction, ey3. Now if you observe properly, the x component of this wire and the x component of this wire are getting cancelled. So this component would cancel out this component. What is electric field in y component? So ey1 is equals to how much? K lambda by r, which should be equals to ey3. So the total downward portion of electric field due to these two wires is nothing but 2 into k lambda by r, but this is getting added twice. Understood? Now the portion is for semicircular arc. For a semicircular arc, we apply the same formula. E arc. What is the electric field due to arc? Kq by r square into sine phi by 2 divided by phi by 2. Okay. What is the value of q? The value of q is nothing but lambda into r phi. okay, or charge density into length. So E arc should be equals to K lambda R phi divided by R square into sine phi by 2 divided by phi by 2. So same type of calculation, R and R square will get cancelled, phi and phi would get cancelled out here. 2 would go up out here. So the remaining portion are K lambda or E due to arc, or electric field due to arc, is nothing but 2K lambda by R into sine phi by 2 into sine phi by. Now what is the angle phi due to the semicircular arc? Phi out here is nothing but 180 degree. So 180 divided by 2 is nothing but 90 degree. So this would be nothing but sine 90 pi by 2, or 180 divided by 2 is nothing but 90. The value of sine 90 is nothing but 1. So the total electric field due to semicircular arc in horizontal distance will be 2k lambda by r. 2k lambda by r. What is the downward portion of electric field? So downward portion of electric field is nothing but, or E total is equals to E y1 vector plus E y3 vector minus of E arc. Okay, if I'm considering downward direction as positive and upward direction as negative. You can do the opposite also. Okay, E arc minus EY1 minus EY3. It doesn't make a difference out here. You understand why? Okay, or E total. What is the value of EY1? K lambda by R. K lambda by R. What is the value of EY3? K lambda by R. And the value of electric field due to semicircular arc is equals to 2k lambda by R. 2k lambda by R. So if we add these three, it becomes 0. So the total electric field due to this shape is equals to 0 at this. Understood? Okay. It doesn't matter if you take the upward direction as positive and downward direction as negative. Okay. Now see this question. Okay. In this question, what is given is a infinite rod is there. Okay. And at the end of the rod, a circular ring is there. Okay. The linear charge density of the rod is given as lambda. Linear charge density means charge per unit length, or total charge divided by total length. Okay. And what is the amount of charge in the ring? Q charge is given to the ring. Okay. Understood? Both are positive. This lambda charge, this means wire has also positive charges throughout. This ring also has positive charges throughout. Okay. The question is asking, find out the total electric field, or find out the total force interaction between this ring and the rod. That means this rod will try to push the ring away. Equal and opposite reaction force will be applied on the ring by the rod. Okay, both will try to repel each other. No, the question is asking, find the force of repulsion between the rod and the ring. So this is why we have done question number 13 first. See out here. If I see the rod clearly out here. Okay. So if I want to find out the electric field out here, okay, for a semi-infinite rod of charge density lambda. So what is the electric field? Ex. The electric field Ex is nothing but K lambda by R. Ex is equals to K lambda by R, where R is the distance from the rod. Similarly, what is the Y component of electric field? Ey is equals to K lambda by R. Now see, how do I apply this electric field or electric field at this point in this entire circuit? See, a rod is a 3D structure, no? Suppose this was a rod, okay? Suppose this was an infinite rod. If I want to find out the electric field x component of electric field was equals to K lambda by R. What happens if I want to find out the electric field out here? The electric field out here would be K lambda by R in this direction. The electric field out here would be K lambda by R in this direction. The electric field out here would be K lambda by R in this direction, isn't it? So if I draw a circular rod out here, a circular ring out here, okay, out here, what would be the force? it would be towards this direction, not upward. This direction. Now, how do I draw? See, when I'm drawing this direction, no, just assume it in this direction. Okay, this direction means perpendicular or towards yourself. Okay, this is a circular ring. The electric field at this point, or the electric field at this point, the x component of electric field, it's towards yourself. So ex would be k lambda by r, k lambda by r, and ey would be k lambda by r, k lambda by r. Similarly out here, ex would be in, see, for a ring, okay, in this direction. Okay, the ex component would be in this direction. So ex would be k lambda by r, and ey would also be k lambda by r. Okay, so if you see throughout the ring, okay, if you see throughout the ring, the x component of this portion will cancel out the x component of this portion. The x component of this portion will cancel out the x component of this portion, isn't it? At the bottom, what is the electric field? Ex is equals to k lambda by r, and y component is equals to k lambda by r. So if you see, the x component throughout the ring will cancel out each other. Only what will remain? The y component of electric field, no? Okay. So the total y component of electric field out here is nothing but Ey is nothing but k lambda by r for a semi-infinite wire, isn't it? Where r is the radius of the ring. Where r is the radius of the ring. Understood this much? What is force? Force is nothing but charge into electric field. Okay. Now electric field due to this semi-infinite wire is equals to k lambda by r. Okay. Now the total charge on this ring due to this semi-infinite wire would be charge q, which is the total charge on this ring, into electric field that is created by the semi-infinite wire, isn't it? So total force on a ring is equals to total charge on the ring, which is given by q. See, given by q out here. Okay, the total charge of the ring q into electric field. The electric field, that is the y component of electric field. Okay, which is equals to k lambda by r. K lambda by r. So total force on ring is equals to k q lambda by r. Similarly, if I apply Newton's third law, okay, if the rod is pushing the ring with this force, okay, the ring will also push the rod with the same amount of force. From Newton's third law of motion, or from Newton's third law, from Newton's third law, what will happen? F on wire, F on semi-infinite wire due to ring would also be k lambda by or kq lambda by r, equal and opposite reaction force. So this was one of the method in which you solve question number 3.11. Okay, there is another method. Okay, just take an dx element out here, find out the hypotenuse, convert all the hypotenuse terms and vertical terms or x. See, x dx. Convert all the x and dx terms and hypotenuse terms in terms of r and theta. Then integrate it. After integration, put the limits. Minus 5 is equals to 0, phi is equals to 90. So you can do it by that method also. But since we already have derived the same thing for infinite wire, no, or a long wire, a long straight wire, so you do not need to go to the entire calculation again and again. Just apply this formula, it will be done. Understood?